In our previous videos, we explored ways to speed up Raman imaging by reducing time needed for each measurement point. Today, let's talk about a different approach, cutting down the number of points we measure in the first place. When you are doing research, some areas of your sample are critical, where you need a small step size and high-resolution imaging. Some spots, like empty parts of the substrate, might not even be worth measuring at all. If you can see these regions clearly on the optical microscope, it's easy to set up a Raman map with different parameters for each area, keeping your experiment short and efficient. But what if you are relying on Raman signal to find your target, like searching for a specific material? Now it's like a treasure hunt. Traditionally, Raman imaging scans point by point, line by line, driven by the way sample stage moves. It gets the job done, but it's not the smartest way to hunt for treasure. The cover system we mentioned last time gives us amazing control over laser precision, letting us scan in a much more flexible way. Here's how it works. Let's say you are looking for a substance that shows up as red in your Raman data. You start by randomly measuring a few points across the sample. When you hit a red one, it makes sense to focus on that area, measuring points close to your find with smaller step size and create a high-resolution Raman image of that region. Then you go back to scanning randomly across the rest of the sample until you spot another red signal, and you zoom in again for detailed mapping. This approach can be powered by AI-based algorithm called random scan. It is a little bit more complex but follows exactly the same idea. The result, random scan can produce the same high-quality Raman images while measuring up to 90% fewer points, all without any user intervention. For more details of this technique, please check the link in the video description below. Thanks for watching and see you next time.